So next we'll discuss Stoke's statement of phase change on reflection. Okay. So suppose here we have a surface AB, okay, which is separating two medias. This is medium 1 and this is medium 2. Okay. A ray is incident on the surface AB along PO. Then it is reflected along OR and transmitted along or refracted along OQ. Okay. And now suppose the amplitude of the incident ray is A. Okay. So when it is reflected, a part of the ray, a part of this amplitude will be reflected and the rest of the part will be transmitted along OQ. Now suppose that there is no absorption for this surface A. So the ray which is incident will be partly reflected and partly transmitted. Okay, there will be no absorption. So generally what happens when a ray is incident on a surface of a medium, there will be reflection, transmission and absorption, but here we are assuming that there is no absorption, only reflection and transmission. So now suppose R is the reflection coefficient of the surface AB in medium 1. It means that when a ray is incident on the surface AB which is travelling in the medium 1, like this ray, this PO ray is travelling in the through the medium 1 and then it is incident on the surface AB. In this case, the fraction of amplitude which will be reflected back in the medium 1 is R. Okay, so the reflection coefficient is basically the fraction of amplitude which is reflected when a ray is incident on the surface AB travelling in the medium 1. And small t is the transmission coefficient from medium 1 to medium 2. So it means that when a ray is travelling in medium 1 and is incident on surface AB, then it is transmitted or refracted to the second medium 2. Then the fraction of the amplitude which is transmitted to the medium 2 is T. Okay. So the ratio of the amplitude of the incident ray and the ratio of the amplitude of the refracted ray or transmitted ray and the amplitude of the incident ray is equal to T. Okay. So so this is the case. So T is the transmission when the ray is travelling from medium 1, then it enters the medium 2. Similarly, R prime is the reflection coefficient of the surface AB in medium 2 and T prime is the transmission coefficient from medium 2 to medium 1. It means that, so when a ray is travelling in the medium 1, then it is incident on the surface AB, then the fraction of the amplitude which will be reflected in the medium 1 is that. Similarly, when a ray is travelling in medium 2, okay, travelling in medium 2, then it is, suppose in this direction or this direction, but it is travelling in medium 2, then it is incident on the surface AB, then it will have a different kind of reflection coefficient, not equals to R, because now it is travelling in the different medium 2. So in that case, the reflection coefficient is given by R prime, means that when it is travelling in medium 2 and incident on the surface AB, then some part of the ray will be reflected back in the medium 2. Then the ratio of the amplitude of the reflected ray in medium 2 and the incident amplitude of the incident ray in medium 2 is equal to R prime. Similarly, our transmission coefficient when a ray is travelling in medium 2 and then it is transmitted to medium 1, in that case the fraction of the amplitude of the incident ray which is transmitted from medium 2 to medium 1 is equal to T prime. Okay. So now in this case, when the incident ray PO has a amplitude of A, then what will be the amplitude of the reflected ray OR and the transmitted or refracted ray OK. Okay, so the amplitude of the, so we can write that the amplitude of OR, amplitude of reflected ray OR so we know, now we have just said that amplitude of reflected ray OR divided by amplitude of incident ray OP will be equal to, because OP is incident in medium 1, okay, it is incident in medium 1, everything happens, this reflection happens in medium 1, then it will be equals to the amplitude of reflected ray divided by amplitude of incident ray will be equal to the reflection coefficient in medium 1. Therefore, A, which is sorry, not this one, so we can say that amplitude of reflected ray OR is equals to this reflection coefficient in medium 1 multiplied by the amplitude of incident ray. Right, so what will be the amplitude of reflected ray OR? So amplitude of OR is reflection coefficient, which is R, in medium 1 it is R, into the amplitude of incident ray A. So arranging, let us write it is equal to A. Similarly, what will be the amplitude of transmitted ray AQ? So by definition, like we have said, the transmission coefficient, amplitude of transmitted ray OQ divided by, which is in medium 2, right? It is in medium 2, and then divided by amplitude of incident ray PO, which is in medium 1. So a ray is transmitted from medium 1 to medium 2 will be equals to transmission coefficient from medium 1 to medium 2. From medium 1 to 2. Okay. So now we want to find the amplitude of the transmitted ray OQ. So amplitude of OQ will be equal to the amplitude of incident ray PO into the transmission coefficient, which is A into T. Okay. Now what we will do, keeping the incident ray incidence O, that is the point of incidence O, fixed on the AB, we will assume that the directions of the reflected ray OR and the transmitted ray OQ are reversed. That is, now they are traveling along RO and Q. Okay. So in such case, the figure will look like this. Suppose this is the point of incidence O. Okay. Now this is RO. Now the direction of RO is also changed. The direction of QO is also changed. Okay, OQ, now it is the ray is traveling along QO. Then what will happen? So you can say that now a part of RO is reflected along OP, and then a part of QO is then another part of RO is transmitted along, suppose SO. You are drawing SO by dotted line. And similarly, a part of QO is reflected along, suppose OS. Okay, OS. A part of QO is reflected along OS, and another part is transmitted along OP. Okay. So now, in this figure, like we have already found out that this OR has an amplitude of AR and OQ has an amplitude AT. Okay. Now this ray of amplitude AR and another ray of amplitude AT is incident on at point O, like this one. Okay. So here a ray of amplitude AR is incident along RO, another ray of amplitude AT is incident along Q. So, and a part of this ray RO is reflected along OP and transmitted along OS. Similarly, a part of this ray QO is reflected along OS and transmitted along OP. Then what will be the reflected part of RO, amplitude of reflected part of RO, this one, and what will be the transmitted amplitude of transmitted part of RO. Okay. So now if we write amplitude of reflected part of RO, which is reflected along OP, it will be the reflection coefficient in medium 1 into amplitude of RO. So it will be reflection coefficient in medium 1, because this reflection, incidence and reflection happens in medium 1, into the amplitude of the incident ray, which is RO. So reflection coefficient medium 1 is R, and the amplitude of RO is AR, we know this. So it will be A R square. Okay. Now what will be the so suppose this is equation 1. Okay. Now what will be the amplitude of transmitted part of RO, which is along OS. Okay. So amplitude of transmitted part of RO along OS. So this is the transmission which happens from medium 1 to medium 2. So it will be the product of the transmission coefficient from medium 1 to medium 2, from 1 to 2, if I write in this way, medium 1 to medium 2, into the amplitude of the incident ray, which is RO, into amplitude of incident ray, which is R. So the transmission coefficient from medium 1 to medium 2 is T, and the amplitude of RO, we already know it is R. So it is equal to ART. Okay. So this is equation 2. So this happens, so the reflected part is of RO is reflected along OP, whereas the transmitted part is has gone along OS. Now there is the another ray which is reversed, which is the actually transmitted ray OQ. Now it is traveling along Q after reversal. Okay. So what will be the amplitude of reflected part of QO? So the reflected part of QO which is happening, so this is the medium 1 and this is the medium 2. So this ray QO is incident on the surface AB in medium 2, then it is reflected along OS. So here we will use the reflection coefficient R prime in medium 2. Okay. So R prime is the ratio of the amplitude of this reflected OS and the incident Q. Okay. So the amplitude of reflected part of Q is equal to reflection coefficient in medium 2, because this reflection, incidence and reflection happens in medium 2 into the amplitude of incident ray Q. Amplitude of Q. So, which is equals to reflection coefficient in medium 2 is R prime into amplitude of Q, we know it is AT. So, it is AT R prime. Suppose this is equation 3. Similarly, now we will find the amplitude of the transmitted part of QO which happens along OP. So, the ray is incident along QO, then it is transmitted in medium 2, then it is transmitted in medium 1 along OP. So, here we will use the transmission coefficient from medium 2 to medium 1. Okay.